Please take a minute to try this daily warm-up. Please pause the video and give this a try. Using the area model, we get x minus 5 times 2x plus 3. This is our first day of graphical models. So in this case, I'm just looking to discuss the relationship in each of these graphs. So we've got Jack's babysitting earnings on the y-axis, hours worked on the x, and you can see that that is going at a steady rate. It's linear because he's making the same amount of money each hour. One of the other things about Jack's babysitting wages is that if he doesn't work, he doesn't make any money. This is called a direct relationship because the hours worked directly relate to the earnings earned. Now, compound interest over time. If you remember from last year when we talked about compound interest, you earn interest on your interest, and so it is an exponential relationship. And in an exponential relationship, your rate of increase increases over time. So it is an increasing rate of increase or an increasing rate of change. So here we have the temperature of a cooling cup of coffee. This is also exponential, but in this case, it's exponential decay because the temperature of the coffee is decreasing, but at a decreasing rate. And note that the temperature of the coffee is never going to zero. It will only go to room temperature. And lastly, we have crop yield. Now, hopefully you can identify that this is a quadratic relationship because there is a maximum. And from the maximum, it goes up to the maximum, and then it falls after it reaches the maximum down to a zero crop yield. So as you notice, so the fertilizer used doesn't start at zero in this case, but they're trying to see how much more fertilizer they should apply to the field to maximize the yield. But notice that if you go too much fertilizer, you're actually poisoning the crop and you will get less yield over time. So this increases at a decreasing rate, because notice how it's increasing and then it's slowing down till it gets to its maximum, and then it is decreasing at an increasing rate. Here's a graph showing the number of births in Ontario from 1945 to 2005. What you can see here is, just for fun, you can kind of see the generations. And I'm sure that you guys know the term baby boomers. And the baby boomers were what happened, or the result of people returning home from war. And there was a huge spike in birth rates after people returned home from the Second World War until about 1960. And then I guess people decided they had enough children, and then the births actually went down from there. Things were changing in our society and in culture, and so birth rates started to go down. And then you can see, and honestly, I don't really know why, but we had a spike there in about 1990. And then the birth rates went down again. And at this point, at the end of this graph, it showed a slight upward tick again towards the end. Now, this is just in Ontario. This is not global. And so when you ask to describe the trends on a graph like this, you would say things like, well, it is increasing fairly quickly, and then it decreases for a number of years, and you would outline the number of years. And then after about 1975 here, you can see that it's fairly flat to 1985, at which point there's an increase from 1985 to 1990, and then it plateaus off again. This example asks you to calculate the average rate of change between each pair of points. And then what does this rate of change represent? Well, hopefully you can remember back to your linear relations where rate of change is the slope And so all we're being asked to do here is calculate the slope between 2 points. Now, on the graph, like we had on the last page, so example 2, you could calculate the exact rate of change for each 5-year period by calculating the slope between those 2 points. In this case, we're only being asked to calculate the average rate of change because we don't know if there was a difference in the height of the airplane from 0 to 4 minutes. We're going to make an assumption that it did not all of a sudden plummet 600 meters from 0 to 4 seconds. We're going to assume that it made a gradual decline from there, so that it was gradually decreasing over 4 minutes. It went down 600 meters, or it decreased its altitude at a rate of 150 meters per minute between 0 and 4 minutes. We've got now the vehicle rental cost, distance driven over rental costs. So this is a per kilometer charge, which we can figure out because when we drove 200 kilometers, we ended up with a $300 charge. You have to watch your scale in these cases. So we're going from $400 to $700 in costs when we went from 200 to 400 kilometers. So we can figure that out as a kilometer or dollar per kilometer cost. So if I reduce that fraction, 300 over 200 is the same as 3 over 2, which means it was $3 for 2 kilometers or $1.50 per kilometer. And that $1.50 per kilometer it's considered our average rate of change, but because this is rental cost, that would just be our rate of change. I've given you those 2 points, so we're calling it our average rate of change because we can do that on any graph. We can calculate the average rate of change by just identifying 2 points on the grid. So that is it for this lesson. It's not a very long one. You can now carry on and do the practice questions.